Welcome back guys to my channel, and today we will be studying about chapter 8 of our maths textbook, Quadrilaterals. So the chapter starts off with the angle sum property. So let's see how to prove that angle sum property of a quadrilateral is 360 degrees. So for example, if we take a quadrilateral like this, okay, and then we draw a diagonal. We say this A, B, C, D. So here we have drawn a quadrilateral and there's a diagonal, and the diagonal cuts the quadrilateral into two triangles, and we know the angle sum property of a triangle, that this angle plus this angle plus this angle will be 180 degree. So let us note this as angle 1, this angle 2, and we'll note this as angle 3 and angle 4. So we can write that angle A plus angle 1 plus angle 2 equals to 180 degree. Okay, and then the second triangle, angle D plus angle 3 plus angle 4 equals to 180 degree. So this is our first equation and this is our second equation. Now let's add both the equations. So angle A plus angle 1 plus angle 2 plus angle D plus angle 3 plus angle 4 is equal to 180 degree plus 180 degree. Now what is angle 1 plus angle 3? Angle 1 plus angle 3 is angle C. So angle A plus angle C plus angle D. Now what is angle 2 plus angle 4? Angle 2 plus angle 4 is angle B plus angle B equals to 180 plus 180, 360 degrees. Hence, we can prove that the angles of a quadrilateral, the sum of the angles of a quadrilateral is 360 degrees. Now let's move forward and see some of the properties and the proof of the properties of a parallelogram. So the theorem 8.1 states that the diagonal of a parallelogram divides it into two congruent triangles. So let's see that. For that, let's first prove it. Okay, so proof. We have a parallelogram. We have a parallelogram. Let's name it A, B, C, D, and there's a diagonal. Okay, so now we have to prove that these two are congruent triangles. So what are the basic details we know of a parallelogram? We know that the opposite sides are parallel. So we know that these two opposite pairs are parallel. So if these two lines are parallel and there's a transversal running, we can say that these two angles are equal. So we have now that these two angles are equal. Similarly, we have this angle equals to this angle. Opposite interior angles again. So we come to know that angle ABC is equal to angle DCB, and angle ACB is equal to angle DBC, which is because of alternate interior angles. Now we can see that these two angles are equal, and this side, the BC, which is a diagonal, is a common. So we can tell that these two triangles are congruent. So let's write it down. So we know that BC, okay, we'll write it in stepwise order. So in triangle ABC and triangle DBC, we know that BC is equal to BC because that's common. Now next we have angle ABC. Angle ABC is equal to angle DCB because of alternate interior angles. Now next we have like similarly we have angle ACB is equal to angle DBC because of alternate interior angles. So therefore we can tell that triangle ABC is congruent to triangle DBC using A as a congruency. Henceforth, we have proved that a diagonal of a parallelogram divides it into two equal halves. Now moving forward, we will see the next theorem. Okay, the next theorem 8.2 states that the opposite sides of a parallelogram are equal. So how do we prove this now? Let's see. Let's take up the parallelogram again. And A, B, C, D. Let's take the diagonal again as well. So we know that these two triangles are congruent. Now, if these two triangles are congruent, we can tell that AB and CD are equal due to CPCT, and AC and BD are equal due to CPCT similarly. So it's quite simple. In the last theorem, we had proved that the two triangles are congruent. So as the two triangles are congruent, we can tell that these two sides are equal because of CPCT, and AC is also equal to BD because of CPCT. So I will be again showing how we prove this congruent. But when you are proving this theorem, you must show how the two triangles are congruent. So I'll just directly start off. Proof. So triangle ABC is congruent to triangle DBC. Oh, sorry. DBC because of ASA. And then we have, therefore, AB is equal to CD because of CPCT. And similarly, AC is equal to BD due to CPCT. So this is how we prove this theorem. Now let's go to theorem 8.3. Theorem 8.3 is a converse of the previous theorem. So according to this theorem, if a quadrilateral, if the opposite sides of a quadrilateral equal, then it is a parallelogram. So here we have the same diagram again, but here we already have the details that AB is equal to CD and AC is equal to BD. So using these details, we will be trying to show that ABCD is a parallelogram. So let's see. We can tell that these two triangles are congruent because of SSS, because you can see that all the three sides are equal. AB is equal to CD, AC is equal to BD, and BC is common. So we can tell that these two triangles are equal. If these two triangles are equal, we can tell that this angle is equal to this angle, and this angle is equal to this angle because of CPCT. And how we had told in the first theorem that as the alternate interior angles are equal, then the two triangles are equal. Here it's quite the opposite. Here we proved that the two triangles are equal. So these two triangles are congruent, and we can see that the alternate interior angles are also equal, which means that these two are parallel and even these two are parallel. And if the opposite sides are parallel, then we know that it's a parallelogram. So let's see. We have that in triangle ABC and triangle DBC. We have AB equals to CD given. Then we have AC equals to BD given. And then we also have BC is equal to BC because it's common. Therefore, triangle ABC is equal to triangle DBC using SSS. Now, moving forward, we can tell that angle ABC is equal to angle DCB because of CPCT. And then similarly, angle ACB is equal to angle DBC because of CPCT. Therefore, I'm continuing here. Therefore, we can tell that AB is parallel to, therefore we can tell that AB is parallel to CD, and as well that AC is parallel to BD. Why? Because of alternate interior angles. Hence, we have proved that if the opposite sides of a quadrilateral are equal, then it is a parallelogram. Now let's go to theorem 8.4. Theorem 8.4 states that the opposite angles in a parallelogram are equal, which means that it is saying that these two angles are equal and even these two angles are equal. So let's see how. Now, in the first In the first theorem, we had proved that these two triangles are congruent. So if these two triangles are congruent, this angle and this angle are equal, and even this angle and this angle are equal. Why? Because of CPCT. Um, and as they're congruent, even these two angles become equal. So we can say that these two angles are equal. Angle A is equal to angle D. Why? Because these two triangles are congruent, and we can take the parallelogram again. A, B, C, D, and we can take another diagonal. So we'll take AD as diagonal. So similarly, we can prove these two triangles are equal again, and we'll find that angle C is equal to angle B. Why? Because of CPCT. So we anyway have proof that these two triangles are congruent, hence these two angles will be equal. And if we take another diagonal, then we can prove that angle C and angle B are equal as well. So like that, we can tell that all what we can do in this triangle itself. If angle B is equal to if angle ABC is equal to DCB, and if angle ACB is equal to DBC, then likewise the addition of these both will be equal. So let's see how to prove it. So I will be again proving that these two triangles are congruent. So I will just write that triangle ABC is congruent to triangle DBC using ASA that we have used, and then we will be showing that angle A is equal to angle D using CPCT. So we got that one pair of opposite sides are equal. Now let's prove this. Here we know that angle ABC is equal to angle DCB because of CPCT, and then similarly we have angle ACB equal to angle DBC due to CPCT. Now what we can do is that we can add. Now when we add both the sides, we'll find that angle ABC plus angle DCB is equal to angle ACB. Sorry. We'll find that angle ABC plus angle DCB, angle ABC and angle DBC is equal to angle ACB plus angle DCB. Why? Because if these two are equal and these two are equal, then even the additions will be equal. Just what Euclid had told in Euclid's geometry, that if two things are equal, then even the additions will be equal. So accordingly, we can tell that angle C is equal to angle B. Or what we can do, we can take the same quadrilateral but a different diagonal, and we can prove that these two are equal, these two triangles are equal, and we can prove that these angle C is equal to angle B. Even that might be an easier method, whichever you can choose. So now let's see the next one. So let's see theorem 8.5. Theorem 8.5 states that if the opposite angles of a quadrilateral are equal, then it's a parallelogram. Here I have designated the opposite angles with a variable. So angle A is equal to angle D, and I have designated as X, and angle C is equal to angle B, and I have written it as angle Y. So we know that 2x plus 2y is going to be 360 degree. Why? Because of angle sum property of a quadrilateral, which means x plus y is going to be 180 degree, half of 360. So I can say that angle A, which is x, and angle B, which is y, are supplementary. So angle A is equal to angle B, which is 180 degree. So I can tell that AC is parallel to BD. Why? Because if we see that A and angle A and angle B are co-interior angles, yes. And if co-interior angles are equal, no, co-interior angles are supplementary, then we can tell that the two lines are parallel. So here AC and BD are parallel, and AB is a transversal. So we can write that AC is parallel to BD. And similarly, we can tell that AB is parallel to CD as well. Therefore, we know that now these two are parallel and even these two are parallel. And if the opposite pair of sides are parallel, then it's a parallelogram. So let's see the next theorem. The theorem 8.6 says that the diagonals of parallelogram bisect each other, which means that AO is equal to OD and OC is equal to OB. And how do we prove that? Well, we can prove that you're showing that a triangle AOB is congruent to triangle COD. And how do we show that? So let's see. We can tell that AB is equal to CD because opposite sides of a parallelogram are equal. Then we can also say that this angle is equal to this angle. Why? Because we can tell that this side and this side are parallel. AB and CD are parallel, and AD is a transversal. So the opposite interior angles will be equal. Similarly, we can also tell that this angle is equal to this angle. Why? It's the same reason again. AB and CD are parallel, are two lines, and BC is another transversal. So these two are also equal. So we can see that two angles and a side is equal, which means that the two triangles are equal using ASM. So here we can write that in triangle AOB and triangle COD, we have AB is equal to CD because it's given. Then angle BAO is equal to angle CDO. CDO because of alternate interior angles. And then similarly, even angle ABO is equal to angle DCO. Same reason. So therefore, these two triangles are equal. Triangle AOB is congruent to triangle COD using ASA. And therefore, we can tell that AO is equal to CO. Wait 1 minute, maybe an error. So, AB is O is equal to DCO. So A is congruent to D, then B is congruent to C. So it's DOC. So AO is equal to DO and OB is equal to OC. So we have proved that these two are equal and these two are also equal. So we have proved that the diagonals are bisecting each other. Theorem 8.7 states that if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. So here we have the detail that AO is equal to OD and CO is equal to OB. So we have to show that ABC is a parallelogram. So let's get started. To show that, first we can prove that any of the two triangles are equal. So here I'm taking AOB and COD again. So in triangle AOB and triangle COD, we have that AO is equal to DO given, we have CO is equal to OB given, and then we know that these two angles are equal because of vertically opposite angle. So angle AOB is equal to angle COD because of vertically opposite angles. Therefore, we can tell the triangle AOB. We must be very careful that which part is corresponding to which other part. So here, A corresponds to is D. Triangle DOC using SAS. So triangle. Now we have proved that these two triangles are equal. So if these two triangles are equal, we can tell that this angle is equal to this angle. So angle ABO is equal to triangle angle DCO because of CPCT. Now because these two angles are equal, we can tell that AB and CD are parallel because of alternate interior angle. Therefore, AB is parallel to CD because of alternate interior angles are equal. Similarly, we can also tell that angle AC is parallel to BD. Therefore, we have proved that the given quadrilateral is a parallelogram. theorem 8.8 is another condition for a quadrilateral being a parallelogram. So here the theorem 8.8 states that if any one pair of opposite sides are equal and parallel both, then it's a parallelogram. So let's see how we can prove it. So we have already that AB and CD are equal, and we also know that AB and CD are parallel and BC is a transversal, which means that this angle is equal to this angle, and we have BC common. So we can prove that these two triangles are equal due to SAS. These two are equal and this is common and this angle is also equal. So hence we have proved that these two triangles are congruent. After proving these two triangles are congruent, we can tell that even these two angles are equal. So if opposite angles are equal, then it's a parallelogram. So, and there are various other things as well. So any other property we can use and find out that this is a parallelogram. So let's see. Um, so we can take that in triangle ABC and triangle DBC. So we have AB equals to CD already given. We also have BC equals to BC common, and then we have angle ABC is equal to angle DCB because of alternate interior angles. Therefore, we can tell that triangle ABC is congruent to triangle. Now again, we have to check which corresponds to which other part. So we have to write triangle DCB using SAS. So we have proved that those two are equal. Now using CPCT, we can tell that these two angles are equal as well. So if these two angles are equal, then even AC and BD are parallel because of alternate interior angles. So we can write that angle ACB is equal to angle DBC because of CPCT, and then we have therefore that AC is parallel to BD. Why? Because of alternate interior angles, and therefore we can write that it's a parallelogram because then all the because the opposite sides will be parallel to each other. Then therefore we have proved that if one pair of opposite sides are equal and parallel, then it's a parallelogram. Now moving forward, we'll be seeing two very important theorems belonging from the midpoint theorem. So let's see what midpoint theorem says. The midpoint theorem states that the line joining the midpoints of two sides of a triangle, which means that the line segment joining E and F. E is a midpoint of AB and F is a midpoint of AC. So it says that the line joining the midpoint of two sides of a triangle is parallel to the third side and also half of the third side. So here it says that EF is parallel to BC. EF is parallel to BC and also that EF is half of BC. So let's see how we can prove this. So we have to do some construction here. So here we are going to draw a line. Say we have CM, and then we are drawing CM such that it is parallel to AB. So before we go to proof, we have to write down the constructions we are doing. So we have construction. The construction is that draw CM perpendicular to AB. I mean parallel to AB. So here we have AB and CM parallel. Then another we have to do that extend EF to intersect CM at D. So we have to extend EF and intersect it at CM at a point called D. So after doing this construction, we have this type of a diagram. Now we have to show that EF is parallel to BC and EF is half of BC. And how do we show it? First, let's start off by showing the congruency of the triangle AEF and CDF. So let's see. We start with a proof. So, in triangle, let's see. So here we have that angle AFE and angle CFD are equal. Why? Because of vertically opposite angles. We also know that angle A is going to be equal to angle FCD. Why? Because of alternate interior angles. And we also know that AF is equal to FC. Why? Because F is a midpoint of AC. So we can now tell that according to ASA, the two triangles are equal. So in triangle AEF and triangle, let's see the congruency, CDF. CDF, we have AF equals to CF. Then we also have that angle AFE. AFE is equal to angle CFD because of sorry, because of vertically opposite angles. And then we have angle EAF is equal to angle DCF because of alternate interior angles. Therefore, we can tell that triangle AEF is congruent to triangle CDF because of because of ASA. Now, after we have proved congruence, we have proved these are congruent, we can tell that CD is equal to AF, and we know that AF is equal to AE is equal to EB. So these two are also equal. So we anyway know that AB is parallel to MC, which means even EB is parallel to CD, and EB is equal to CD as well. So in the previous theorem, we had seen that if the opposite sides of a quadrilateral are equal and parallel, then it's a parallelogram. So going to the next part of the proof, I'll just erase this. So now we can write that AE is equal to CD because of CPCT, and we knew anyway that AE is equal to BE, it was given. Therefore, BE is equal to CD, and if CM is parallel to AB, then even CD is parallel to BE, which is already there because of our construction. And is given that BE is parallel to CD. So therefore, BEFC is a parallelogram. And if it's a parallelogram, then we know, then even we can tell that these two are parallel and equal. So now we have done our first thing. So therefore, we can tell that EF is parallel to BC because BEFC is a parallelogram. Now let's go to the next part of showing how EF is half of BC. So you remember the congruency. So now as these two triangles are congruent, we can tell that EF is equal to FD. Because these two triangles are equal, EF is equal to FD because of CPCT. Therefore, EF is half of FD, and we had seen that FED is equal to BC. So, and we had already seen that ED is equal to BC because it is a parallelogram. It's a parallelogram. So we know that these two sides are equal. And if EF is equal to half of ED, then it is also equal. EF is also half of BC. Therefore, we have proved the midpoint theorem. So what did we do first? We first proved that we first did some construction. We constructed a line CM which is parallel to AB. Then we extended EF and intersected it at CM at a point called D. So we got two triangles there, EAF and CDF. Using ASA, we proved them congruent. Using proving them congruent, we also use CPCT, so that CD is equal to AE. A is equal to BE, so CD is equal to BE, and they both are parallel as well. So BE, oh sorry, wait, I made a mistake. It was not BEFC is not a parallelogram. BEDC is a parallelogram. Just change that. BEDC was a parallelogram. So as they are a parallelogram, ED is parallel to BC. So if ED is parallel to BC, your EF is parallel to BC. And we also know that ED is equal to BC and EF is half of ED because F is a midpoint of ED. As these two triangles are congruent, EF is equal to FD. So F is a midpoint of ED, and as ED is equal to BC, EF is half of ED, so EF is half of BC as well. So like that we can prove we can prove midpoint theorem. Now the last theorem of this chapter is the converse of the midpoint theorem, which we'll be proving now. So the converse of the midpoint theorem, or the theorem 8.10, says that a line segment from the midpoint of one side, so EF is a line segment from the midpoint of AB, which is E, parallel to the second side. So EF is parallel to BC. It's already given to us now. Bisects the third side. So it bisects the third side, AC and F. So what does the midpoint and converse say? It says that the line drawn from the midpoint of one side, which is parallel to the second side, bisects the third side. So we have the details that E is the midpoint and EF is parallel to BC. But we have to show that AF is equal to FC. So which means we have to show that F is a midpoint of AC. So we will do the same constructions again. We draw CM parallel to AB, and we then extend EF and intersect it at CM at a point called D. So we have this scenario right now. So what to do next? So here we know that EF is parallel to BC, so ED is also parallel to BC. So while proving we know that ED is parallel to BC because it's given. Now we have constructed CM in such a way that it's parallel to AB. So again, CD will be parallel to EB. CD is parallel to EB. Therefore, BC, BEDC, BEDC is a parallelogram. Why? Because the opposite sides are parallel to each other. So we also can write like this. So we come to know that BEDC is a parallelogram. Now if they are parallelogram, then the opposite sides are equal. So we can write that B is equal to CD. Now because B is equal to CD and B is equal to EA, so EA is equal to CD. Now we'll go to proving the congruency. So we know that it's a parallelogram, and then we'll go to the congruency in triangle AEF and triangle CDF. We know that EA is equal to CD. Why? Because B is equal to CD as it's a parallelogram, and EB is equal to AE because E is the midpoint. So AE is equal to CD. Now as AE is equal to CD, and we can take an angle again. These two are equal because vertical opposite angle. So angle AFE is equal to angle CFD because of vertically opposite angles. And then after that, we can write that even these two angles are equal. So because alternate interior angles. So angle AEF is equal to angle CDF because of alternate interior angles. So we can write that triangle AEF is congruent to triangle CDF using AAS. And as these two triangles are equal, we can write that these two sides are equal because CP/CT. So AF is equal to CF due to CP/CT. Therefore, F is the midpoint of AC. So we have proved the converse of the midpoint theorem as well. So how to prove it? We do the same constructions as we did in the previous one, and here we already have the detail that EF is parallel to BC, so ED is parallel to BC, and we construct CD parallel to EB. So as opposite sides are parallel, it's a parallelogram, and even opposite sides of parallelogram are equal. So CD is equal to EB, which means CD is also equal to AE. So as they are equal, and these are what vertically opposite angles, and these are alternate interior angles, the two triangles are congruent. And as the two triangles are congruent, AF is equal to CF of because of CP/CT. Therefore, the converse of midpoint theorem is proven as well. So this is where our chapter quadrilaterals comes to an end. I hope you liked the video and you understood all the proofs that we had done, all the 10 proofs related to parallelogram and the midpoint theorem. If you liked it, then please subscribe the channel and like the video. Thank you.